Hello, everyone. So, after my giant refactor, I've been a giant addition of the control flow graph. I've been thinking about how to manage the lifetimes of particular objects in the code better. One case that I have considered is the way we handle the types. As you notice, we have here a bunch of floating type pointers that are just statics in say primitive type, right? Right? We have a bunch of type here. And you'll notice that they're all static to the class. This is not, I feel, a very good way to do this sort of thing. Because the type pointer, if we can find where that's declared, is just a shared pointer. Which means, yes, you're free to copy it. But there are issues with allocation and with that copying may be too much, and also it's both of these are non-movable, but I find that using shared pointer is not really the idea I want. I want something more like LLVM system that uses raw pointers. Now, to do that transfer, we need to have somebody that owns all the types. And for that, I think we can write a type context. So to write a type context, first ask whether we have defined an AST type context HPP. And if we have not, we shall define it, and otherwise we will then end it. This will be in the AST namespace, and will also include the type.hpp. Right? So this class, which we will call type context, it will be a final class. You cannot extend from it. We will write that with it, and we will write it in mind. Publicly, you should be able to construct it, and it should have a default constructor. We'll worry about the defaulting of a constructor later. We are not going to make it copyable, so I don't find that it should be copyable. Also, I feel it should be non-movable, though this may be a lot extra from what is actually needed. And then finally, the destructor should be no except, and we'll just default all of this as well. For now, I'm fine defaulting. So need a way to add types to this. Actually, wait, this constructor can't be defaulted, because if it is defaulted, we can't generate the basic types. So we need to be able to construct types. So if I make a new down here, and then come back over to here, let's see what types can we have. We're going to have a way to return a type pointer. And we'll make this no discard. Type pointer. Let's see, can we create a type? In order to create a type, we need to work over a templated T that extends type. Yeah, that's probably what we'll have to do. We'll have to have a templated function. Create type, and it will be the templated type name type. Yes, truly a great name. Type. And then the rest of the args, type name arg type, of course. Type. And then here we'll just take in the archetype args. Okay. We'll need some private data, and that will store the, for now, let's use a vector containing the type pointers. Call it the types. The quality of types is going to be interesting because we have to have some way to make certain types equal checked. Yeah. Well, for now, yeah, we'll figure it out. Ooh, I will. Oh, for now, I'll be fine writing this. Hmm, yeah. There's got to be a. I'll figure out how to work with the create system. Yet. So now we get to open up the type context CPP. And then we'll split that over. And that will be this guy over here. And we will include the type context header. And it says AST. We will have the type context. And it can't just be defaulted because we have to add in, if we jump over to this guy here, we have to add in all these types. So the way to do that is going to be, we could use our create type function. Yeah, create type. Um, hmm. We'll create the type for AST prim type, and all we get to input is AST prim type Boolean, let's say. Which then means we can just yank all these types, paste them down, and for the, let's see, how do we do substitute on this? Grab everything up until the second opening curlies, which will start on AST, and we'll grab everything here, and we'll say AST should go until, as long as there's no closing curly, star, okay. Yeah, that grabs everything we need. And dot star after that. Okay. So now we get to say void cast in order to explicitly ignore the no discard. Create type of AST. So here, we're going to create all the types. Yeah, and look at that. And then I'll just order these sorted. Yeah. I think for now, yeah, create type's going to be an interesting little thing. Hmm. Yeah. So find if this type exists, immediately followed by add if not found. Well, first we have to find whether the type exists. So this will be a very interesting little function because the so I think here if we're gonna have to if const expr over this stuff, which is gonna be very fun. Stood is same value. So if the type that we're creating is the same thing as AST prim type, we know that that type exists, so we need to find return find prim type. Find prim type of. We'll also static assert that size of the arguments that we take in is exactly equal to 1. Because if it's not exactly equal to 1, it's not a primitive type, because primitive type always takes exactly one item. Find primitive type of args unrolled. And for now, we'll just unroll it, but we know at this point it's 1, so we should be fine. Yep. I'll write here all primitive types should have been made by the constructor. There. Yep. Else if const expr, of course, the next thing. The next type, let's go for if it is AST null pointer or non-null pointer. Just see something. Can the pointer type tell us what it's been pointing to? Yes, we can have the pointed to type. Okay. So if the type that we're looking at is the same thing as non-nullable pointer type, or it's the same type as the AST nullable pointer type. So if it's either of these, that's ugly. I'll write a to-do in here. So to-do fix formatter. Works formatting. Yep. So here, if that's the case, I think it would be better to write it like this. Delegate to functions that can either return that will enforce each type's uniqueness rules. Yep. So here, return find the pointer type find the pointer type args. We'll also do the static assert for args because we know there's only one of them. And I think what we can also do is we could say here, we're going to have to pass in whether this is null or not. Sadly, though, this is a runtime value, so we don't really know. Yeah. Yeah, we'll have a bool for nullable. So I'll write the headers for the functions here. So no discard, of course, just writing no discard and everything. Type pointer to find prim type. This will take the single argument that is the AST prim type sadly, we have no better name. Sadly, there's no better name for this. This is now the pointer type. Bool is nullable. And then we'll take in the AST. We'll take in the pointer, the type pointer for pointed to. There. Okay. So we have those two so far. And then else static assert false no. I want to print out the type name, though. That is going to be a tricky thing. For now, I'll just add it as a static assert false. I wish this was else const expr. I'll leave it at that. Let this generate some strange thing if it doesn't agree. Okay. So now here we're going to write the concrete functions. So the type pointer from type context, find prim type. If only there was a way it could automatically generate this. So sad. Prim type, type. Should always find a prim type. So now for every auto ref pointer in types, every type pointer. Okay. So for every one of those, if std, I think we can use standard pointer dynamic cast. With an undefined behavior attempting to delete the same object twice. Yeah, we should use this. So this should be AST prim type to the type pointer. Auto footer is this. Does not equal null pointer. Okay, so we have this here. So we now, at this point, we know we have a primitive type. Can we tell what kind of primitive type it is? We should be able to. Sadly, though, I don't know if we can. We might need to add another API to do this. Yeah, I think we should. So, type, this will be a no discard. Type inner. Let's just call it the inner. That's const no except because we know that this cannot throw an exception, and it cannot throw an exception, and it can be accessed in a const value. If footer arrow inner exactly equals type return footer. Could technically return type pointer as well. At this point, I think we really should do that. And then here, assert false to do. We may want to lazily allocate. Primitive types. Yep. And then here we say, and now let's do the one for the pointers. So, type context, find pointer type, which is a bool nullable, is nullable, and then the type pointer for inner. It's copied for each allocation, make it a reference. I'll worry about that later. Right now, we have to do the same walk. And instead of being a point, instead of doing this, we'll dynamic cast it to a putter type. If we don't have a way to tell. Oh, we do have a way to tell whether this is nullable. So, yeah. Okay, so if the putter arrow nullable is exactly equal to the is nullable parameter and the type pointer, the inner, and the type, well, and the putter arrow pointed to type is the same thing as inner, we can then return our pointer. It's not the inner, it's the pointed to. Which I can just change down here to pointed to. There. And of course, now we have to figure out what happens if we do run out. Well, if we do run out, we then need to say if is nullable, else. So if this is a nullable pointer, we now need to create the nullable pointer type, which can be created using the create function. I think really these should have public constructors. I'm feeling these should have public constructors. Yeah. For now, we'll just use the create to not change too much. So this would be the AST. Well, this would be the nullable pointer type create pointed to. This would be the non-nullable. Do not use else. Yeah. Actually, I'll turn this into a ternary then. If you don't want me to use else, I'll use a ternary on you. Question mark, colon. Expected operator. Yeah. Okay, I get what's happening because they're not able to be casted down. There's gotta be a nice way to static cast them. I think you can. I think you can ask for a static cast to an AST type pointer for this guy. Okay. That makes sense. It tries to find the common base, and the common base is that. The other option is to use a shared pointer, and we'll cast it down to AST pointer type. Okay. Yeah. That handles the uniqueness parameters. Yeah. So let's see what other things we've got. We have the pointer types. We got the primitive types. User allocated type. This would be like structs, I believe. Yeah, module name, string name. Right, we do a lookup. Let's see what that's like. We do a lookup. We ask user made types to look up the module name and this guy. Oh, no, that's wrong. User made types. This is a shared pointer. Interesting. I think I could leave user made type alone for a bit. Yeah, probably, because it covers struct and function. Now let's do function, because function I understand. So for function, else if const expr stood same as, change this with the type t. This would be the AST function type. So if we have the function type, we'll now static assert that the size of args is 2, is less than or equal to, well, no. It can't be 0. It can't be 0, and it can't is greater than 0, and the size of, well, actually, no. Let's keep the and as a separate thing. So it can't be, it has to be greater than 0, and then it has to be less than or equal to 2. Yeah. Yep, that makes sense. And then we will return find function type, taking in the spread of the args. Which we'll do the same logic here. Find function type. Yank inside the parens. Yep, that makes sense. Though you'll probably want to steal here, so I think I can ask for, it'd have to be forwarded. Let's see, to do use stood forward. I will worry about that later. Right now, we'll just do that. Type pointer, type context, find function type, which will have an AST type pointer return type. L. Okay, so we use the term ret type down here. I think I'll use the full name, return. And then we'll immediately follow with vector of type pointers. God, maybe I should clean this up. I'm not going to use the AST prefix because we're already in the same namespace. Yeah. There. Okay. Then we have amps argument types. So, okay, so we have there, type pointer. And then we want this to be the function type. So for a function, we need to check that the here we're actually going to do it the reverse wise. We'll say something like if footer arrow return type is not the same as the return type we're handed, continue. If footer arrow arg count does not equal argtypes dot size, continue. Okay, so now we know those are the same size. I starts at 0, I is less than footer arrow arg count. Increment I, please. Comparison of unsigned, so we get there. If the footer arrow arg at, so the argument of I is not the same thing as the argtypes at I, continue. And finally, at the end of this whole thing, return the pointer. Yeah. So that's how we ensure the uniqueness of function types. But now at the very end, if we actually need to create one, yes, we'll send that in here by saying return create. And the creation will take the return, will move the return type and move the argtypes. Yep. And we'll do the same thing. I should do the same thing up here. Order that this be moved and order that this be moved. Okay. And that's the function type. So the only thing we're missing is the struct type. So the struct type is part of is a subclass of the user-defined type. Just a little water. Helps with the thought. Helps with thinking. So we have fields. Can we construct a user-defined type? I think you can. There's nothing. Yeah, user-defined type can just be like constructed. Why would you let that happen? Oh yeah, because a user-defined type could be an enum, say. So we do need to distinguish the two. Though we should say something like else if constexpr same if the type that we're looking at, the type we're trying to construct, is the same type as the struct type. Then we will say, well, let's see. In order to construct a struct, so we need to take 3 arguments. That is the name, the module name, and the fields. Yes, because 2 structs, if they have different definitions and different modules, are different structs. So static assert that the size of args is exactly equal to 3. Return find struct yep. So we find the struct, type pointer, find struct type. Struct type field type. Yep. Okay, so take this. We're now going to say that we have type context redundant for declaration. Yeah, don't care, because it's not going to be for declared anymore. Now we're actually going to do stuff with it. So to fix our redundant declaration, we're going to do some dynamic casting. So the first dynamic cast we're going to say is we need to dynamic cast it down to the struct type. Let's see. So the user-defined type carries around its name, but it also doesn't carry around the module it's from. It should, though. Okay. It should really carry around the module that it's attached to, because we're not going to allow user-made types to be a thing here. So we should carry around the module that we're associated with. Yeah. Actually, I'll just have a std string module module name. So I'll have to say that's the username in the particular module. Module name. parens to be a curly, to move the module name in. Yeah. User type. Odd. What does create do down there? Okay, we tried to look up the name. So here we construct a new string. Right, we construct a new string because otherwise this add type fails. What if we say that this also should take the module name? Which then will be here. So induce a copy, which then we can std move the module name. Okay. Because it's all hidden behind create, we'll be fine. So let's go through here. How do we check that the struct is a struct? We should be able to access the module name. So we should say no discard constant string ref module name is const return module name. Reference to a non-static member must be called. Ah, I see why. Let's call it containing module name. Yep. That is, which module contains it. If putter arrow containing module name does not equal the module that we are handed, we shall continue. If putter arrow username is not the same thing as the name we are provided, continue. If arrow field count is not the same as the field's size we are given, continue. And then here, it's less than the pointer arrow field count. Yeah, so all this check is doing is we're saying it should be declared in the same module, has the same name, has the same number of fields, and we should also say that the field at the particular index should, if it does not equal fields at I, we continue. Yeah. There. Otherwise we get to pointer. Now here, if we actually need to construct the type, we will then say return the struct type. Create, which will take in the name, the module name, and the std move and the move result of the fields. Okay. Yeah, that should be fine. Let's see if that builds. Should build decently. Yeah, no problem. Look at that, it builds with no problem. But for now, we need to close out. We need to read what's happening here. Now, we need to commit these changes here before we commit anything for the other stuff, because processor for inner prim type enum. Yep. So that when we land the changes, okay, so accessor is not a, oh, you're wrong. It's actually a valid word. Yeah. Yeah. So now we get to do this, and this, and this, and this. So we need to land these changes first before we work on type, because we need some way for the type context to do the quality comparison. So here, we now say user type now stores the module name that contains it. Yep. Okay, so now we have type context. I will add these, and in order to add them, I have to come over to AST CMake lists. And for CMake here, we've got the type. We also need the type context now. Context.cpp. And there's no build issues? Excellent. Then we get to add everything in. Star. Yep. Initial run. Of a type context. This class will act as the sole owner of all types currently type pointer is still a shared pointer. But with this change, we can switch to raw pointers in the future. There. So now we run that up. That's fine. Okay. Now I need to think what to do. We might have to use friend classes, sadly enough. Yeah. Yeah, it's sad. So these need to be eliminated. So let's see how we would do this. I want to forbid creation at all. So the way to forbid creation would be to say that these are that this create is actually a private thing. It's non-copyable, non-movable, and the only thing you can check is whether it's nullable. Okay, yeah, that makes sense. But I want to say this is ugly, 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 but okay, that is good. Now we have to pass a type context into the parser. Yeesh. Okay. So when we create from a file or from a buffer, both of these need to create a type, or both of these need to pass a type context. So we need not a const, we just want a type context ref, type context. Okay. AST type context, yes. And then from buffer, we'll also need to pass in an AST type context reference type context. Yep. And then here, we will now need to pass in the AST type context ref type context. Ah, yes. Okay, so we have a bunch of extra functions here. What we do need, though, is down here, we need to get the lexer. Well, we'll take the type context. Yep. Reorder the field, please. And on top of that, we'll follow our convention of only using curly braces. Let's go to this here. Let's see if I can do this. So if we return the type context dot create type AST nullable pointer type parse type. Okay. That makes sense. But we also need to come up here and now do this as well. Type context ref type context. I forget, does it go here? I think it does go here, type context. No, it doesn't. It goes in the middle then. Yeah, there it goes. Okay. Yeah, type context. Yeah, there. Okay. So now that that's fixed, make again. Okay. Ah, I have to update this stuff. Um, this is a question. So, if we were to get the type context, we'd have to, I think I know what to do. Uh, auto parser. Let's context grab everything. This needs to be an open paren. Star. And then we'll grab everything up until closing paren, semicolon. Well, actually, no, we don't need the semicolon just yet. We'll exclude the closing paren here. Okay. So we get to say AST type context, \1, comma, type context, close, and the semicolon's already there. Up. That is lovely. The fact that we can just create 20 different type contexts. Yeah. The other option is we could have one type context that is global for the entire program. No, I think I'll be fine if I don't. Yeah. Let's see, so if we do this. Sorry, I had a cough there. So let's see. Let's fix main. So main, when we parse from a file, needs to have a type context. Okay. Okay. Read module. Problem is that this type context has to live for the same length here. Yeah, this is way too high, low level for main to be handling. Yeah. To do. Main should not be making a type context. Yeah. Okay, so now that that's done, let's do the serializer test because I see that as an option. So here we have same thing as previous, where we have to create a type context. This is the parser test, the new parser test even. Ah, yes, we can't create the type here, but what we can say is we could ask the type context dot create type of AST type context. No viable conversion from a shared pointer AST type to a print. Ah, create a type. You're right. 41. And instead of the prim type here, we'll ask for the type. Okay. And then here, testing AST to CFG, which is a very complex test, and I would really like to simplify it. AST type context, tie context, of course, and then here we get to just pass in the tie context. Time. Okay. The parser, store the type or no, make the parser use the type context for creating types. Actually, no, we don't want to grab everything. Yeah. Yeah. Let's gap it. We don't carry this. No, we're not going to add that. Yes, 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 yes. No, no. Yes, 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 yes. All in this file, all in this file, all in this file. Commit. Make the parser take a type context. This will be used in the future to enforce. Let's just say to create all the types during compilation. Okay. AST type .hpt. So let's get the other one up. Actually, let's do the user type stuff. So Actually, wait, what if I return? Wait, no, that requires publicness. Yeah, so we have to do this. Besides, it also lists our changes. Well, if these are asserts, we should include them. Now that is so much simpler now. Look how much code deletion we can do. It's always a lovely day when you can clean out all this code. Printing types, yeah, that's fine. Okay. And let's see. So type. Nullable pointer's already there. Let's go for the non-nullable pointer. Private. But we get to rend class. Type context. Okay, yeah, that should be included here. This needs to be included, so we need to grab include global map HPP. Tie context. Create type. Non-null pointer type. Parse type. Okay, so now we do the slow refactoring where okay, linker command errors. Oh, I see why. Because we removed the user type lookup here. I see the problem. We need to create something similar in the type context, because you can't just, so we need to be able to have it. So we need to say something like no discard type pointer lookup user type std string name. This will be by reference and const reference even. And for const std string ref Module name. Yep. And then we will ask for the type context, full file, find prim type, find all this stuff. I think it should be at the bottom here. Okay, these are unused. So now type pointer in types auto putter is dynamic pointer cast, and this, remember how we added that lookup ideas into the uh, the user type, right? Well, we have here an excellent use case for it. So you want to dynamic cast this to AST user type pointer. We get a pointer. We check that the pointer is not null pointer. And then we say here, if putter arrow containing module name is the module name we are handed, and putter arrow username is the name we were handed. We return that putter. And at the very end here, we can just return null pointer. That will error up there. Yep. Swap that, and we can use type context dot lookup user type. That's a concrete function, so calling it isn't a problem. Let's see if we run that up. We fail. In this operator, we have an undefined reference to the lookup. I think it would be easier to remove lookup in here. Yes, it would be easier to remove the lookup. Yep. And look at that. We have it in the, if we remove it from the header, it's so much simpler. Plus 37. Possible struct. Huh. Let's see, because this logic, when we have a struct, nah, this logic won't happen. Assert that those are not empty, and here, instead of taking that, we can just order remove. Okay. Yep. That's good. So let's figure out what we can add here. I just noticed that, so let's just run a formatter. for source, AST, type context. Let's see what we got here. Yeah. Allow users of type context to look up user-defined types. Hmm. Add include explicitly. Yeah. Yeah, okay. Time to really ruin my day. So prim type I'll leave alone for now. User type we're good on. This is so far what the yeah, let's try. Yeah, let's just do this so far. Let's make a good. We got a good halfway point. Um, so let's commit the parser. Is create type for pointers and look up I could technically do this better by not having the end. Well, just do that. And let's patch that. Nope. Yep. Use create type for pointer types. Commit, and then we'll ask the parser look up user types in the type context instead of the global user type. Actually, no, let's say instead of AST. And then let's try committing the removal of the user type stuff. Nope. I won't clean up the imports just yet. Clean that up. We're at the point where I could argue for this. No, I won't do that yet. No, I won't do that yet. Yes, I will do this. Yes, I will do this. Yes, I will do this. No, I shall not do that just yet. Make pointer type create functions only accessible from type context. Yeah, look at that. This is the reason I'm making this thing. You see 33 deletes? That's not even the whole thing. We've got other logic to clean out, like uh, the lookup. The thing with the lookup, though, is we'd have to clean out the struct type. Yeah, which we should do next. Let's get the struct type together. So this here will become private, and then we just have to. Do we put this at the very end? Do we put the friend class stuff at the very end? Yeah, we put it at the very end. Okay. Let's build that. And then here we say AST nodes, create as a private member. Huh. Plus 23. What the heck is happening here? Oh, we don't create the struct. Right. Okay. So the struct declaration, when we declare a struct, previously we would delay creating the type until such a time as we could. But now that we can't delay it, and potentially we shouldn't delay it because we always have to type check a struct, so there's no reason to delay, so the delay really doesn't help. We now have to ask the parser. There's two options. Either we can store a reference to the type there, or it would be easier to say that struct decl type. Maybe type. No, type shouldn't be a thing. Maybe it should be a thing for all expression nodes. This is an expression node. Yeah. Or no, it's the top level node. Okay, so a top level node, function declaration, const declaration, struct declaration. I think it'll carry around the type instead as a shared pointer. AST struct type. Yep. Yeah, that's fine. We need that because we're having that. Yeah. Okay. Redefinition of type. Yes, type does get redefined. You are correct. But now we don't have to worry about that. Parser CP 271. So instead of creating a struct, what we can do auto struct type is, I love these tricks, you know. You can get good stuff out of lambdas these days. Of course, the formatter breaks when I do this. So I will assert struct type does not equal null pointer. Well, okay. You're right, though. This is still a private member, so what if we return tie context dot create type AST struct type. Delete that. Find the paren. String created off of that. Yeah, we're fine, we're fine. No viable overloaded equals. Okay, inform me, why is this not viable? Note the candidate's not viable because you're trying to convert from a type to a const. Oh, I see. I see. Because it thinks that the left-hand side is actually an AST type, not a shared pointer to our individual type. So the way we fix that is we ask the type context to, instead of return any type pointer, let's ask it to return auto. And then here, where needed, let's say we can make this a shared pointer to an AST struct type. Yep. I wonder if that works. Yes. Okay, so then the out-of-line type is going to be wrong. 65. Which then means here we just have to say that this is a... Wait, can I say auto here? Is that valid? Nope. Has to match the definition, sadly. Shared pointer about an AST struct type. Okay. Okay. Well, creating a specialized pointer. There. Okay. So we have that, but our next error is that we cannot find struct. HPP line 37, eh? Find struct. You are right. find struct doesn't exist because we couldn't. Because it's find struct type, my friend. R value reference to a basic string cannot bind that. Yep, this is the forwarding issue. I have to do perfect forwarding now. So if I were to perfectly forward this, okay, so let's build up. Struct type. Okay. Actually, I'm going to say that in the top level items, so instead of this being a shared pointer to a struct type, well, yeah, I'm fine with it being a shared pointer to a struct type. Do you use shared pointer anywhere else? No. And we do have it there. I think it'll be fine. As an implicit dependency, it's fine. Yeah, it's building, so it's an implicit dependency. Uh, okay. Okay. We just gap this together. Yep, I want to carry that. Yep, I want to carry that. Yep, I want to put that in. I want to skip all of these, so do not. No, but I think... Yeah, for now I'll leave these in. Yeah. Yeah, this is fine to have. Compute the type of a struct declaration. In the parser, let's just say eagerly. Yeah. And look at that. That's a removal of lines. Struct function. Let's do the struct computation. So git commit. Yep. This is the CPP file. Nope. split this up. Yep, let's use that. Nope, let's not use that. Nope, let's not use that. Yep, let's use that. Yep. Yep. Right. Yeah, that's right. Yep. Yep. Require struct lookup and creation to be done through type context. Look at that, 31 lines deleted. Okay, now we get to do function. I think function may be the last type. Let's see, we did the pointers. We did, well, primitive I'm still going to have to work out because that is a bit of a horrendous little change. So this here needs to move down here. And we'll friend it to the type context. No, that's not what we want. Type context, please. Okay. Created as a private member, and that is in source AST. Oh, right, we also lazily calculate this stuff. So this is a top level node. And for a function declaration, instead of having the type out here, in fact, we can just switch out this and say that this should carry around a shared pointer to a AST func type. Well, it's function type. Let's call it func type. Yep. Implicit dependency, please. And then here, we don't get to do that anymore. Huh. Okay, so this file may not be needed. That'll be a change later. So for right now, let's do that. Oh! Oh, okay, that is a lot. So let's walk backwards. So first, we need to go to the serializer, about line 68. Yeah, the parameter doesn't need to be there. We can just assert that the function type is not null. And in that case, we'll ask for func type arrow return type. There. Oh, that's easy. So if you see this many errors, here's a little trick I like. Nope, it's the other thing. We just dump everything into a log.txt. Then we can open log.txt and run from the top. So the first thing we need to say is this func type is not a called thing anymore. You're right. 398. Right, it's not called anymore. There's no return type member. You're right. There's not a return type that we need to do. Is we need to create the function's type entirely. So func decl func type is equal to type context dot create type AST function type. Which reminds me, what the heck is a function type? How do we create a function type? We ask the AST type header file. How do I create a function type? We create a function type by passing in the return type and the arguments. So move the return type and the argument type. Move arg types. Auto ref arg in. Where do I find that? The args. Unidentified variable args. Arg types dot pushback. And this is the part where the code base is so big, so old that I forget things. So in top level nodes, we have a function declaration. We give typed identifiers. Okay. A typed identifier carries around a type. Very good. Vector cannot be bound to an L value. You're right. We have the... We need to open up that, and we need to go grab perfect forwarding into the type context. And look, it's that to do. Yeah. Yeah, let's see what that does. Let me open up the log. Okay, no viable overload because we think it should be a function type, but it's not. You're right, it's not a function type. We need to force that. So we need to say down here, line 216, create type, go to the declaration, find function type takes a stood shared pointer to function type. This is a shared pointer, AST function type. Then pipe t, log.txt. I'm gonna gap in the AST type context because I think we should add that. Nope, we don't need that. Yep, we do need this. Yep, we do need that. Yep, we do need that. Types for function type. We need to forward its inputs and return a, and it should return a specialized pointer like find struct type does. There. Yes, throw that away. Okay, so that failed up. But now we check that the return type here is not right. Or wait. So the way we should check the return type is we should say function arrow func type arrow return type. Much better way to write it. Should be there might need to be an easier way. Though for right now, I don't really see a need to write an easier way. I am perfectly happy leaving it as this, having a double deref in here. Oh. Okay. Yeah. So we have that. I think that's fine. Let's see if we run Ninja on that again. Okay, there's still some test errors. But we're very close to done. 497. Okay. Yeah, yeah. Okay, fine. So if that's the case, we can commit the let's commit everything except let's just gap it in. Yes, I want to drop that. Yes, I want to add that in. Yeah, we do move that, so it's fine to do that. This is fine. This is fine. We're gonna skip this file because I don't think we want to do that just yet. We're gonna skip this file as well because that's just forcing it. Yes, yes, yes. Everything in this file, please. See if we status that. It's not too bad. Eagerly compute the type of a function declaration. Yeah, okay, okay. And that's perfectly fine. Return type can be accessed from the function type. We do not need to store it separately. There. 8 deleted lines. And then commit everything here. And we get to say require function types be constructed through type context. 21 deletions. That is so good. Okay, I think I have enough time to try for the... I think I have enough time to try for getting the primitive types in. So, let's get those types together. So the first thing with the primitive types is we can't do this. This just doesn't work anymore. Okay. So now that that's done, I'm going to friend the type anyway. I need a friend. Yeah, I do need... No. Actually, prim type's weird. It doesn't need to friend class. Yeah. To do. Prim type. This class has no need to be friends with type context. Okay, bubble. Of course, it's going to spit out like 20 billion errors. Need that, please? 20 billion errors. So we now look in the log and start from the top. Actually, wait. No, we can't do that. Yeah. So here, this is actually the... No, you know what? Okay. The LOVM type lowering. LOVM type lowering does require a constant type. Very interesting. Yes, very interesting. So, we'll worry about that later. Type checker will need that. Let's go here, because this is the easiest thing to remove. This is just a bulk delete. Watch. Ready? Boom. Bulk deleted. Um, eight. We do have a type context. Actually, we can say something like this: %/AST print type. We can say here, I'm trying to figure out how to capture everything that isn't. We have A-Z 0-9 underscore one or more. And once that's done, we can do this for the type context dot create type AST prim type AST prim type \1 close parent slash. These are the same actually. Okay, well. That'll fix later. Type checker, we don't have a type context in. Parser, we do have a parser here. 190. That's good. There. So pre-allocating, I'll fix that later. So right now it's easy. Yeah. Them up on the log. So we don't have LLVM type lowering because that doesn't have it. We don't have type checker doesn't have a type lowering. Type context has an error because why? Why are you wrong? Cannot initialize a parameter of that with the type value of this. Hang on. Oh, that's wrong. 142. Oh, that is very wrong. Okay. So I think I'm gonna have to pause the recording a bit, but I'll come back because we've got a lot to do, and I need to have a little bit of a break. Hello. So I think what I'll do now is I'll just see what progress we've made. I think the parser we can say, yeah, the parser and the tests we should say switched over to create type. The parser and tests to create type AST prim type. Right. Okay. So we have that. Now we need to figure out the next things. So in the log, we have three classes, it seems, that are broken. LLVM lowering, type checker, and config and the CFG to LLVM. So let's tackle LLVM type lowering. It's the top of the list. Okay, so here we're going to have a we're going to have to carry around the type as well. Yes. Do we not? I have to check the context, but I don't know that we carry around. Okay, let's grab here, and we'll say that we want the AST type context reference tie context. To be very explicit that we want that. And additionally, I think we should... so we grab this guy. AST type context ref, type context, use parameter. So here, I think what we'll write is for every auto primtie in type int32. Actually, no. Easier way to do this would be to say s/ opening curly AST prim type. Let's grab everything starting from here. No, we can't. Because we need to grab... I'll fix it. Anything that's not closing curly, 0 more times, close paren, closing curly followed by the comma. And here we get to say active types dot emplace AST prim type \1. Yep. Close paren and on a semicolon. Yep. The thing is, this in place is wrong because it's asking for those types. Instead, we will say is anything that says AST prim type anything is 0-9 A-Z star because active types, yeah, it takes type pointers. So that will be followed by type context dot create type AST prim type \1 in there. Yep, okay. Very long thing. Using prim inner is equal to AST prim type. Let's see how this works. Prim inner. That's lovely. This will be prim inner as well. There. So there we find it. Okay. Let's see now if we build this. Okay, so now we have to update program because that takes things. There's all sorts of odd tech debt I have around here. So we have type context. There we are. We have a log here. Constructor doesn't work because we don't have tie context. So here, after the models, we'll take a type context. Load that up again. That's very easy. Look at that. That's so easy. That's just main has a wrong, calls this function with a wrong number of arguments. Need that. Okay, let's see what we have here now. So it's type checker. That's CFG. Oh, that's nice. Now we can write some more commits. Format. And gap things in. Don't want that. We want to not add anything from that file. Not yet. Nothing from this file. We do want to add this file. And this. And yeah, I'll have to go back and add those. LLVM type lowering. LLVM type lowering uses AST type context to get the initial primitives. This is done to get the initial primitives into the lowering mapping. Lowering map. Okay. Then we get to we get to open the log. So let's try the type checker. Yeah, the type checker is going to take this a lot. So if we open up the type checker takes nothing currently. It should take something. Because it needs to care about the type context, type context. Oh, this is the AST type context. Explicitly said this is immovable, which cannot be the case because it is a reference item. Sorry there. I think for now we'll just mark it as non-movable, and we'll see if there's any need for it. Type context amp, type context. And I'll also include it here explicitly. T/type context. So here, we're taking the AST type context. And let's say that the type context is created from the type context. Wait, no, it's the type context? Yes, it is the type context. Okay. So let's get the int. So let's re-edit this. So auto int type is type context dot create type. We'll ask for the AST prim type, which will be defined as the prim type I32. So if it's not equal to int type, get and then it's very easy. Type context dot create type. We'll ask for the same primitive type. Then here and we just delete that. And instead of deleting that, we'll say Boolean, which will be replaced with Boolean type. And I'll extract this out for that. int32, this is actually int type. And furthermore, this will be type. There we go. Okay. So here, trim type, uh, and then we'll say here anything a-z 0-9 0 more. For then we shall get type context dot. I'll steal the dot get as well. Trim type that there. Assigning to this type. No, we're not assigning to that type. We're assigning to AST type putter. Bound identifiers. Huh. That's a bit too extreme. So instead of okay, yeah, I thought it. This is what I get for being short-sighted. Yep. That's a bit long. I think a better way to write this would have I would try something like auto get type is something which takes in the this of the class and should be a prim. This will return the decal type of const type. Okay. Oh, that's a nicer way to write it. Get type of. Okay, yeah. That is a much nicer way to write it. I might need to write that as a thing for the whole class, or some equivalent to it. Okay, let's see what the log now says. So we have more in the type checker, 257. And unit, okay. That's easy to write. As for the type context, to create the type, type unit. Okay. Hmm. Okay. I think this is the part where we ask if it's the... Okay. Auto is prim. And all of these operate over operand. Yes, okay. Operand type exactly equals type context, create the type of AST prim type prim. What is operand prim? So if the operand is not a Boolean, then we do this. Type not equals 0-9 A-Z, or no, A-Z, immediately followed by star. Not is operand prim. It's operand primitive. Now here we just have to create the string type. That is lovely. Look at this. Error, no matching initializer. because for program at 148, we need to give it the type checker. Hmm. What if we need, okay, source program HPP. Okay, so here, we store the LLVM type lowering separately. Right, we have this as a reference. What if the program is non-movable? Called to the deleted constructor because we've explicitly deleted. Right. So it's not going to be possible. Yeah, it's not going to be possible. Let's see, what if we just blaze ahead anyway? So I think here we're running into the issue that this type context needs to be stored as a reference, which we cannot do. The reason we cannot do so, I believe, is because you cannot have a move constructor if you have a reference item. Let's see what that looks like. If we have an AST type context, Tycon, we will have to rename these. To do, sort out the names. Type context. And here, we need to grab tie context, which will take tie context. Defaulting the move assignment. Defaulting this move assignment operator would delete it after its first declaration. Explain? Ah, there it is. The move assignment of program is implicitly deleted because this field is of reference type. Sad. Very sad. What if the only hack I know around this is for the program to carry around the pointer to this instead. Hack. Tie context needs to be a pointer to allow moves. Okay. So here we dereference. And here we take the address of. Okay, that works. I feel that it's wrong. Why is it wrong? Because the LLVM type lowering HPP. Oh yeah, Denver stores it. Right. Okay. So let's just do format pass. And we'll gap in a few things. Nope. 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 Yep, we need to pass that in. Grab everything in this file. Grab this. Grab this. Grab this. Commit. Pass the type context into the type checker. There we go. And if I open the log, this is also why I like log, because then you don't have to rerun your compile. You can just say, what's wrong here? 359. Function type takes. You're right. When we do this lowering, we want to lower. Wait. Could syscall carry around its function type? It could. Every individual call to an intrinsic could have its own thing. Okay, right. New idea. So instead of asking for that, we're going to lower to LLVM the intrinsic call dot type. Very simple. Literal type. Do we carry around the type here? Should be carrying around the type. No, we do. Yeah, look here. For the function, we call the function. The function. So intrinsic call should also carry around its function type. Which means when we lower in AST to CFG, intrinsic call.flow, well, no, wait, the type doesn't exist here. We don't calculate the type just yet. When we run the type checker, intrinsic call, bind call, it results in an end type, but we do want to build up the intrinsic type. So the way to do that is we'll have the vector of type pointer arg types arg type is arg of Alright, we have a problem because type of here does not return the sad. Very sad. Because this requires that we pass in the actual, like, full-on pointers. What if, well, that'd be an internal change. I don't want the LLVM thing to worry about this. Um, well, for now, assert that the intrinsic call dot type is not null pointer. That we will fix later. Okay. So now that we have that, we need to think of how do we do the type checker. est/type header. What we want to do, actually, is because we're moving over to this new idea of types, we should not carry around AST pointers because this implies that the function owns that. Instead, what we really want to say is that we should AST type raw pointer, which then means here we can do the same thing. Raw pointer, which then means here we can also carry in the raw pointerness. And I'll do the change here as well. That the return type should not be an owned type, but rather should be a raw type. Trivially ignorable. Very good. And look, now we don't have to worry about creating that. So now we go to the AST type CP. I apologize for my very disorganized editing style, but this is what happens when you have your code so dependent on each other. There's no move this did move. The argument should still be moved. Okay, okay. Let's see the log. No, it didn't pipe into the log, sadly. Let operands. Okay, yeah, that works, but then we have, let's see, type context line 51. Return type is not this return type. You know what? I think for now it's going to be easier to just nope, we don't want to restore that. Yes, we don't restore this. Nope, don't restore that. Nope, don't restore that. Yes, do restore all this work. I think for now it's going to be easier to so to set the type here in the type checker, it's going to be easier to, I think. So let's build backwards. So to build backwards, type of should not be a pointer type and should instead return type underscore putter. This means that when we use node type, we should not take just the raw, we should take the type pointer. And that also means that when we have type of, that should return a type putter. And that probably means that when we bind the type, we also should use a type pointer, type putter. Because otherwise that's going to complain at us. So argtype, yep. That's really nice. Look at that. You can clean out so many gets. G. Okay. Now once that finishes, I'll fix that. So right now, what I'm doing is everything should just use the AST type. Okay, so here, instead of this, we will say that we have the AST type putter, which should initially be null pointer, and there's no way we can do that, so we can just rip that. And the bound identifiers map also have to use type putter. Ah, okay. So let's see, iterator, we find that. This isn't that anymore. This is a auto to return. Actually, a stood dynamic cast. Pointer cast to internally should be an AST function type. Iter arrow second. That's the case. Okay. I'll let the machine in for the type. Remove that, and furthermore remove that. Pointer. Let's match the previous return type of no pointer. Okay, let's fix that. I can just say that we have a stood putter of, I don't know, of, what would this be, an AST function type? We don't need to get here. And we also don't need to get here. Incompatible types, because we do a dot get here at the end. Should not do that. Return type. Well, we can just delay the dot get then. By type. .get is not necessary anymore. No viable overload because result type is not a raw pointer. Time to do the auto putter type is stood dynamic pointer operand type. There's no match because it doesn't know what the heck we're trying to get at, so we need to ask it for the AST putter type. No overloaded equals because we don't need to .get it. Okay, so what I just did there was now instead of so now the type checker, instead of using raw pointers, uses whatever the type pointer is. Type checker. Type of an intrinsic call and store it. There. Type checker. So now that we go to intrinsic call, so we get here the stood vector of AST type pointers, arg types, which at the very end here we will say arg types dot pushback arg type. In fact, we could technically stood move this, I believe. At the very end. And then here we can say intrinsic call. Intrinsic call dot is it func type? Type is equal to a type context. Create type AST function type oh, it's not intrinsic call, it's the call. Right. So we need to pass in what's the order? I forget these things. So the function type is the return followed by the arguments. Okay. So that's the int type followed by a stood move of the arg type. Arg types. Yep. So that should store it correctly. Then we gap in. Nope, nope, nope. Yeah, we do want to gap that in. Yes, we do have that. Yes, we do want this. Yes, we do want this. Compute the type of an intrinsic call in the type checker. Okay. And then you can finally say remove the prim type constants. That is lovely. Well, now that that's done, thank you for joining me on this rather long adventure. Hopefully, I was able to show how easy it can be to convert from global constant variables to an internal context that carries everything. See you soon.